First of all, we are going to revise the formula of molar conductivity again. So I'm writing the formula. So what we have studied last time, that molar conductivity is equal to kappa upon concentration. So first of all, we have to understand how this formula is changed to this one and how it is similar to how both are similar. So you have to understand that kappa is the unit of kappa, that is conductivity. Unit of kappa, that is conductivity, is Simon per meter or Simon per centimeter. So this one, that is Simon per meter, is SI unit, because meter is used generally in SI units. So but in practical we use this. In practical we use this because generally we have the cell of centimeter of length, in which we are taking our electrolyte. The cell containing electrolyte is generally of centimeter in length. It is not of 1 meter of length. So that's why we use generally this unit. So just to use per centimeter, Simon per centimeter, we have changed our formula from this one to this one. So main formula is this, but it is changed to del m, that is lambda m, equal to kappa into 1000 upon c. So it is taken when we have kappa in Simon per centimeter, and in result we will be getting lambda m in terms of Simon centimeter square per mole. So this is very important. So we can use both the formula, but in this, if I write del m equal to kappa, if I have kappa in Simon per meter, then we have to change, that is we have to change the concentration term. So if we have concentration molarity mole per liter, then I cannot use this formula, because if I have mole per meter, then in talking in terms of SI units, the liter will get multiplied to numerator because it is in denominator here, so it will go up. So by further solving, we have to change this 1 liter to ml to match the units, but it is not similar to, it is not in same unit, that is meter per meter. So we have to change it into centimeter cube. So we know that ml is equal to 1 centimeter, but still we are missing with per meter. We cannot multiply per meter to centimeter. So this has to be changed. This has to be changed in meter. So 1 centimeter is 1 upon 100 meter. So if I have 1 centimeter cube, again I'm writing it by writing in short form, that is 1 centimeter is equal to 10 to the power minus 2 meter. So 1 centimeter cube is equal to 10 to the power minus 6 meter. So to get these terms, we will have to change 1 centimeter cube into 10 to the power minus 6 meter upon mole. Now solving further, we will get Simon per meter, and it is meter cube, so it will multiply with meter cube into 10 to the power 3 into 10 to the power minus 6 upon mole. So ultimately we will lead to Simon meter square per mole, but in numerator we will have 10 to the power minus 6. So ultimately it will go to denominator. So what we have derived here, we have derived that if I have kappa in Simon per meter, then we can use this formula. I'm writing a formula, that is kappa upon concentration into 10 to the power 3, which is 1000. So here, to use this formula, concentration is in mole per liter and kappa is in Simon per meter, and we will get lambda m as Simon meter square per mole. So what we have concluded, so I'm correcting again, I have not written per mole, so it will become per mole. So now what we have concluded that if my kappa is in Simon per meter and concentration is in mole per liter, that is molarity, capital M, molar solution. I'm writing it again, molarity, basic molarity, then our formula will be kappa concentration into 1000. So in here del m we will be getting with unit Simon meter square per mole. So that this is very much important. But if I am using kappa in Simon per centimeter, which is not SI unit, but it is used practically, and concentration is in mole per liter or molarity, basically molar solution, then del m will be equal to kappa into 1000 upon concentration, and here lambda m will be in Simon centimeter square per mole. So we have derived two formula. But if we are using formula lambda m equal to kappa into concentration, which is correct, but here we have to look on each unit. So this is the concept of the formula which I have explained earlier. So I thought I have to explain it again. So this is it. Thank you so much.